Alright, ladies and gentlemen, we are going to do 4.2 today, which is more work with quadratics. So we are going to be looking at that equation in vertex form and in intercept form. Alright, so those are going to be the two forms of the equation that we are going to do today. So let's just go back and look at what we did yesterday. Yesterday we got the standard form for a quadratic. I'm just going to call it a quad. And we labeled, or we had the equation, as y is equal to ax squared plus bx plus c. We can tell lots of things about an equation based on the formula. A determines if it goes up or down. It also determines if it's taller and skinnier or fatter and flatter. C is the y-intercept, so it's a way of helping me graph an accurate graph. So today we're going to get a new form, and it's called the vertex form. Okay? So today we're going to get the vertex form, still of a quadratic, and now it's going to be y is equal to a times x minus h quantity squared plus k. If you'll notice a couple of things, my x is still squared. I have a horizontal translation going on, and I have a vertical translation, and the a from the original equation is the a in the new equation. So both of these particular equations have very specific purposes. The standard form is what your grapher will often give you when it does an equation for you. The vertex form is best if you are graphing by hand. So if I want to graph by hand, that is a nice form for me to use. Okay? The other piece of information about the vertex form is that the vertex of a graph is going to have coordinates hk. My axis of symmetry is going to be x is equal to h. So really, it's very, very similar to the equation that we did yesterday with a couple of minor changes. Alright, so let's just start right off and do an example. So this will be our first example. Alright, so I want to graph y is equal to a negative 1/4, and then I have x plus 2 quantity squared plus 5. Alright, if I start kind of a preliminary assessment, I know quite a bit about my graph. I know that a is a fourth, which means it is a vertical shrink, and that is going to make my graph fatter and flatter. The negative is going to turn my graph upside down. It reflects it across the x-axis. My h is actually going to be a negative 2. Remember, if it's inside the function, it is the opposite sign. And then my k is going to be 5, which means that my vertex is going to be a negative 2, 5. So now I'm actually ready to graph almost the whole thing. I'll just need one additional point to help make my graph more accurate. So if I start the process, I would graph my vertex first, and I know that it's at negative 2, 5. So I'm going to go negative 2, and then 1, 2, 3, 4, 5, and that is going to be my vertex, and I'll put a V underneath it. The axis of symmetry runs right through the vertex. I need one additional point to make my graph be as accurate as possible, so I'm going to choose, so I'm going to let x equal 0, because this point is on one side of the axis of symmetry, and so it will help me have a nice graph. So if I substitute this into the original function here, I'm going to get y is equal to a negative 1/4, 0 plus 2, quantity squared, plus 5. Now I need to simplify that math a bit. So if I do that, I'm going to get a negative 1/4 times 2 squared plus 5. And if I simplify that, I get a negative 1/4 times 4 plus 5. And then if I have a negative 1/4 times 4, I get a negative 1 because the 4's cancel, they're multiplied together. And then I can add that to the 5, and so I get that my y value is 4. So the point that I'm going to use to help me graph, so my extra point is going to be 0, 4. So if I go up to my graph and add 1, 2, 3, 4, here's the 4, there's my point. I know that that's my right-hand side of the graph. If I give myself some guidelines, it's 2 units away. So if I go 2 additional units, has the same y value, now I can draw the left-hand side of the graph, and there is a fairly accurate parabola. Okay. Alright, now let's do another example just to make sure we understand the concept. So this is going to be your next example. The numbered examples, if you can see this, correspond to your book. So if it has a number, that means it is an example in your book. If it doesn't have a number, that means it's just an additional problem. So my next example, we are going to graph y is equal to 1/2 times x minus 3 quantity squared minus 4. The process is going to be very much the same. I'm going to always start by evaluating my a. I know that a is 1/2. It's positive. My graph goes up, and I know that I have a vertical shrink happening, and it's going to get fatter and flatter. Okay? My h is actually going to be a positive 3, opposite sign, and my k is going to be a negative 4. My vertex from the original information is always hk, and so that's going to be 3, negative 4. Okay? So now I have enough information actually to start graphing. So I'm going to draw my graph, and I'm always going to plot my vertex first. So my vertex is at 3, and then 1, 2, 3, 4. It's at a negative 4 right there. It would be so much nicer if I did this on graph paper. There's my axis. So my axis is x is equal to 3. That is your axis. Okay. Now I need an additional point to substitute in to help me get an accurate graph. I'm going to choose the origin again because 0 usually makes the math easier. So I'm going to let x equal 0. And when I substitute that into my equation, I'm going to get y is equal to 1/2, 0 minus 3 quantity squared, minus 4. So this is 1/2 times a negative 3 squared is a positive 9, minus 4. And I know I'm going to have to add these two numbers together, so I'm going to go ahead and multiply this by 2/2. Okay? I'm going to come up here to finish my math, and I'm going to get y is equal to 9/2 minus 8/2, and I get that my y value is 1/2. So my extra point that I need to have a good graph is going to be 0, 1/2. So if I find my x value of 0, and then I go up and I'm going to put that as a 1/2, that is my point. I could reflect that across 3 units, 1, 2, 3, right there. Now I can actually draw my parabola, and it's very nice. So that would be your second example. Okay. All right, so as we move on, we will do your first problem. So this is going to be your first problem. This is problem number 1. This is be where you pause the video or write it down and then do it later. my first problem says I want you to graph y is equal to a negative and then x minus 1 quantity squared plus 5. So that's going to be your first problem that you will turn in tomorrow. Alright, so pause and then finish your first problem. Okay, so now if we start the next part, we are going to just review really quickly because we've added some new information, so I'm going to do a bit of a review. So here are the different forms of the equations for quadratics that we've talked about so far. We have the standard form, and my standard form said y is equal to ax squared plus bx plus c. I know a lot of things about a graph. I know the vertical stretch or shrink, I know if it goes up or down, and I know my y-intercept. So it's actually a very nice form. The next equation that we just learned was called the vertex form, and it is y is equal to a times x minus h quantity squared plus k, and this tells you the coordinates for your vertex of hk. Notice that this a in the standard equation is still the same a in the vertex equation. So the equations can be written several different ways to represent the same graph. So now I'm going to introduce the third type, and this one is called intercept form. And it is written like this. So I'm still going to have my same a, and then I'm going to have x minus p and x minus q. And about the only way you can tell my p's and q's apart is I will usually put a little curly thing on the q's. So let me explain what these are. And I'm going to explain it by way of a graph. Let's say this value is 2 and this value is a negative 2. Okay? Because we are graphing second degree polynomials, which means it has a second degree, it's a quadratic, that means in theory that it's going to have two x-intercepts. Okay? So the x-intercepts, we could say that this one is p and this one is q. And so if I actually wanted to write my equation for this, we're just going to ignore the a for a moment. So I'm going to rewrite my a. My p would be x minus a minus 2, and my q x minus 2. I just need to simplify this. I can't ever leave a negative and a negative because we're doing big kid math. So now I'm going to do x plus 2 and x minus 2. I would then have to determine the value of a, but we're going to do that in a little bit. So that would be how I would write an equation for a graph using the two x-intercepts. So it's a slightly different approach to managing our quadratic equations. Okay? The axis of symmetry in this particular format, so my axis of symmetry, has another handy dandy little formula, and it is x is going to equal p plus q, and then I'm going to divide it by 2. And here's why this formula works. My axis of symmetry is exactly halfway in between the two x-intercepts, or the two zeros, so that way I can average the zeros, and that will tell me the equation for my axis of symmetry. Alright, so let's do an example. So this is going to be example 3 from your book. This is example 3. Okay. This one says to graph, and they're going to give us the equation in intercept form. So this is 2x plus 3 and x minus 1. So actually, when I start this one, I have a lot of information I can put on my graph already. Okay? I know that this has an x-intercept of x is equal to a negative 3, because remember the equation is minus the value of p. So to get a positive, I actually have to have two negatives, and this one is going to be x is equal to 1. So my two intercepts are going to be a negative 3 and a 1. Okay? So if I put those on my graph, here's the -3, and I'm going to put a value. There's my first x-intercept. My next one is at 1. So now what I need to do is find my x-coordinate of my vertex or the axis of symmetry. So x is going to equal p plus q divided by 2, which is a -3 plus 1 over 2. If I keep simplifying, this is a -2 over 2, so this is a -1. So this -1 is going to be where my axis of symmetry is. So x is equal to a -1 is my axis. So if this is my -1, I'm just going to add that lightly to my graph. The only thing that I really have left to find is the other coordinate for the vertex. So I need the y value. So I'm going to do just like we did before. I'm going to run this value through my original function and come up with the y value for my vertex. So I'm going to do f of a -1, which means put that value in this function. So here's the 2. I substitute in the -1, and then I substitute in my -1. Now I need to just simplify that math. Here's the 2. 3 minus 1 is a +2, and a -1 and a -1 is a -2. I have 3 2's, so 2, 4, 8, 1 negative, so this value is a -8. And then I'll write that my vertex is actually going to be a -1, -8. So I'm just going to add that value to my graph, so I need to make my y-axis a little longer. And I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. There's my -8. My vertex is at a -1, -8. I have these 2 points. Okay, so now I can draw my parabola. And there you go. So now we've had 3 different ways to be able to graph a parabola using 3 different equations. Okay? So let's do one more example. Alright, so this is just going to be another unnumbered example. Alright, so I want you to graph. And here's your equation. Y is equal to x minus 3, and x minus 7. So that's going to be our next task. So I know that the a value is 1. Okay. I know that my 2 x-intercepts, so my x-intercepts are going to be x is equal to 3 and x is equal to 7. Okay. So I'm going to let that be my p, and I'm going to let that be my q. So I have an x minus 3 and an x minus 7, and I'm actually going to start sketching my graph. Okay, so I'm going to put my graph. I have an x-intercept at 3, and I'm going to put a dot, and then I have one at 7. 3, 4, 5, 6, 7, just at my outside edge of my graph. Now I need to find my axis. So my axis is going to be p plus q divided by 2. So it's 3 plus 7 divided by 2, which is 10 over 2, which is 5. Okay? Get it focused. Oh, there we go. So I know that my axis of symmetry is going to be x is equal to 5. So there's the 5. I'm going to kind of sketch my axis in there. Alright? So now I need to find the y value of my vertex. So I'm going to substitute this value into my original equation. So I'm going to do f of 5, which means I'm going to put this value into the function. So I have 5 minus 3, 5 minus 7. I'm going to simplify that math. 5 minus 3 is 2, and 5 minus 7 is a -2. And that simplifies to be a -4. So my vertex is going to have coordinates of 5, -4. So I'm going to put my vertex on my graph. So I have 1, 2, 3, 4. There's my -4. There's my vertex. I now have the 2 x-intercepts, so I'm going to connect my dots. And now I have a lovely graph. All right, so here is your second problem. Scoot it up so you can see a little bit. This is going to be problem number 2. You're going to turn this one in to me tomorrow. I want you to graph, by hand of course, y is equal to a negative, and then I have x plus 1 and x minus 5. So your process should look very similar to the process that I did up above, and then when you're done you'll have a very nice graph. And I guess I could label my vertex for my other graph. Alright, so you should pause and do your second problem. Alright, so now the next step in this particular group of information about our quadratics is to be able to change from one form to another form quickly and efficiently, because each form serves a different purpose. So before I do that, I'm going to review the distributive property, and I'm going to show you a way that I do my distributive property. So if I have x plus 3 and I multiply by x minus 4, you could do FOIL, and if you remember, it's the first, outside, inside, last. And then you combine like terms and you work through the process. But I would like to teach you another method in case you haven't seen it, because it makes organizing the terms very neat. So I'm going to draw a box, and it's going to have four cells, if you want to call them that, and I'm going to put an x up there. There's the plus 3, and I'm going to put my other x down here, and there's the negative 4. So if you do the distributive property in a box, it organizes your terms, like terms, along the diagonals. So to get the number that goes in this cell, it's going to be the x times the x. So x times x is x squared. Then I'm going to multiply this negative 4 by this x to get this cell. This is a negative 4x. To get this cell, it's kind of like playing the game Battleship. I'm going to multiply this x times this 3, and I get 3x. And then I'm going to multiply this negative 4 by this 3 to get a negative 12. So if you'll notice, the cool thing about doing this method is that the like terms are on the diagonals, so it makes everything nice and neat. So if I simplify this, here's my x squared. A negative 4 and a positive 3 is a negative 1x, and then there's nothing else for my negative 12 to add to, and then I'm done. So that is kind of a shortcut method to do the distributive property. If you like doing this way with FOIL, I'm okay with that. As long as you get the right answer, I don't care how you get there. Okay? Alright, so now let's try to convert, and I'm going to go convert a quad equation from factored form, which is another word for our intercept form. They tend to use both of those words interchangeably. So factored form and intercept form mean the same thing, and I want to take it to standard form. Alright, so here is your example. This is example 5. Alright, so for example 5, we're going to be given, sorry my paper's wiggly, we're going to be given y is equal to a negative 2 times x plus 5 and x minus 8. This is the intercept form, and I want to take it to standard form. So I'm actually going to do it in 2 steps, and then I'll turn the page over. I'm going to manage this part first, so I'm going to do a box and distribute these two, and then I have to distribute that negative 2 to everything. So I'm going to draw a tiny little box over here, because I'm kind of running out of room, and I'm going to put my x plus 5 right there, and I'm going to do my x minus 8 on the left. It doesn't matter which order you put these in, the answers will always turn out the same. So now I'm going to do my math. X times x is x squared. A negative 8 times x is a negative 8x. X times 5 is 5x. And a negative 8 and a positive 5 is a negative 40. My like terms are on the diagonal. So now this becomes y is equal to a negative 2. And then here's what we just did. Here's the x squared. A negative 8 and a positive 5 is a negative 3x. And then there's the negative 40. Okay? Now I need to distribute that negative 2. So this is going to be a negative 2x squared plus 6x plus 80. And now this is in standard form. And that would be your answer. So I distributed this negative 2. I did this math in my box. Scoot it back over just a little bit. And now my equation, it started in intercept form. It ended in standard form. All right? So let's do another example of that one. Okay, so in a slightly different arrangement. So this is going to be example 6. I am going to give you the equation. I'm going to give you f of x is equal to 4 times x minus 1 quantity squared plus 9. This one's in vertex form. I want you to convert it to standard form. I'm going to do this one in a box, and then I will show you a shortcut later. Not today, but another day. So the first thing that I need to do is manage the x minus 1 squared. So I'm going to do that here. I'm going to put it in a box. Here's my box. And I'm going to do x minus 1 at the top, and I'm going to do x minus 1 on the side. Okay? X times x gives me x squared. A negative 1 times x is a negative 1x. This is still, or is also, I guess it's bad grammar, a negative 1x. And a negative 1 and a negative 1 is a positive 1. Okay? My like terms are along the diagonal. So now this becomes x squared minus 2x plus 1 by combining all of my like terms. So now I'm going to rewrite my equation, because now here's the 4, and then I have x squared minus 2x plus 1, and then outside the parentheses there's my plus 9. So now what I need to do is distribute this 4, and so I'm going to get 4x squared minus 8x plus 4, and then there's the plus 9. The only thing I have left to do is put these two guys together because they are the like terms, and I'm going to get 4x squared minus 8x plus 13, and that would be your answer. So it's cool. It works very, very nicely. Alright, so here is your problem 3. This is going to be where you pause the video, and you are going to do this on that sheet that you'll turn in to me tomorrow. So I want you to write the quadratic in standard form. And I'm actually going to give you 2 of these. So this is going to have an A part and a B part. So y is equal to a negative, and then x minus 2 times x minus 7. That's going to be your first problem. Same direction, second problem. This one's going to say f of x, remember that just means y, is equal to 2 times x plus 5 and x plus 4. Alright, so that is your last problem for this particular set of notes. So do those and then have them ready to turn in tomorrow, plus any questions that you might have. Alrighty, this one's done.